Good morning, and today we are going to see the learning methods in AI systems. Okay, different learning methodologies in AI system. Um, so when we talk about an AI system, what is the importance of learning? Learning is something that improves the performance of the system. That means it can learn from examples, or it can learn from experience, and that will improve its performance in later stages. Okay, so that is the importance of learning, that it improves the performance. Okay, now so another one method of learning is from a collection of input-output pairs. Okay, that can predict the output for new inputs. So that is the common method we follow in neural networks. That means we give a set of inputs, and we know what could be the output of that thing. So suppose we have some applications to identify the faces or identify objects. Okay, so if you want to develop a system that can identify flowers, so what we do is we give images of different flowers as input, and we know that those are flowers, and we feed some other images which are not flowers, and we know the output that they are not flowers. So the input output pair means output could be yes or no. Okay, if the image is a flower, the output is yes. If the image is not of a flower, the output should be no. Okay, so that is the image and its corresponding yes or no answer. So that is called the input output pairs. So we first train the system with a set of images and the set of outputs. We know it is yes or no. Okay, so based on that we will train the system. So after training, if we feed some image to the system, it can identify that it is a flower or not. Okay, so that is the one method of learning or training the system. And why would we want an agent to learn? That means why an agent here in this context we should understand like it is an AI system. Okay, so why would we want an AI system to learn? Okay, why the system should learn? So normally when we consider any programming language, it has any program, I mean any program other than the AI programs, they have a fixed set of inputs and it will have a fixed set of output. It is not learning anything. Okay, it is all the rules are predefined. How to create the output, how to generate the output, all those rules are predefined, and there will not be any change in that rules. That is the common thing in all the computer programs. Okay, everything is predefined. But when we come to machine learning systems, this predefinition is not possible because they have to act like a human being. And these systems, these AI system has to work with some undefined conditions, because when we develop an AI system, the designers cannot anticipate all possible situations that the agent might find itself in. Okay, so for example, you consider that Mars rovers, we sent some robot to Mars. This NASA has sent some robots to NASA to Mars. Okay, so in that case, we, the human being or the scientist, they don't know what is the situation at Mars. Okay, and what kind of situations these rovers or these robots has to face at Mars. We have no idea at all. So if we have no idea, then how we can train them, or how we can give some predefined rules to them, that is, if this happens, it has to react like this, or if that happens, it has to react like that. That predefinition is not possible in most of the cases, in case of artificial intelligence systems. So that is one of the main reason that we say that every AI system has to learn from its experience. Okay, so first thing is, the designer cannot anticipate all possible situations that the agent might find itself in. So that is one of the reason that the agent should learn. Okay, then the second thing is, the designers cannot anticipate all changes over time. Okay, the other condition is what happens in future, what will happen in future, that the designers or the programmers cannot anticipate. Okay, or if they, even if they anticipate, that may not be correct all the time. So that is the other thing. That means over time the system has to learn. That is the second thing. The designer cannot anticipate all changes over time. Then the third thing is, the sometimes human programmers have no idea how to program a solution themselves. Okay, that is the third condition. That means the programmers, they don't know how to program. Best example is Mars rovers. In some cases, what is the situation there at Mars? We don't know. Then how, without knowing that, how we can program the robot? Okay, so that is it. We can anticipate the things to an extent, but we cannot ensure it 100%. Okay, so in all these situations, what is the only solution is, the system has to learn itself from its environment, from its experience, and from examples. That is why we enforce this learning. What that is the importance of learning in machine learning systems or AI systems. Next is the different forms of learning. Okay, any component of an agent means agent is the AI system, can be improved by learning from data. So the improvements and the techniques used to make them depend on four major factors. Okay, the improvements depends on four major factors. One is which component is to be improved. Okay, which is the component that has to be improved, and what prior knowledge the agent already has. Okay, the level of training the agent has, and what representation is used for data and the component. Okay, the data representation methods, and what feedback is available to learn from. Okay, these are the four components, four major factors when we talk about the improvements, or when we talk about the learning. So which component is to be improved, and what is the prior knowledge the agent has, and what representation is used for data and components, and the feedback available to learn from. Okay, so these are the three components, so the components to be learned, and the components of these agents include, okay, the components to be learned are direct mapping from conditions on the current state to actions. Mapping from the conditions on the current state to the actions, and a means to infer relevant properties of the world from the percept sequence. So the components, the first one was condition to action. So in this condition, what action has to be taken, that has to be learned. Okay, then infer the relevant properties of the world from its perception. Okay, when it sees something, how to react to it, or what does it mean, that inferences has to be learned, how to take the inferences. Then information about the way the world world evolves, and about the results of possible actions the agent can take. Okay. According to different experiences or different information, how to react to each situation. So about the result of possible actions that agent can take. Okay. And then the utility information indicating the desirability of world states. Okay. So in that way, some six components have been defined over here. An example is given for the same. Consider an agent training to become a taxi driver. Every time the instructor shouts brake, the agent might learn a condition action rule for when to brake. Okay, so when the instructor shouts like brake, it has to push the brake. Okay, so that is condition action component. That is the first component. The agent also learns every time the instructor does not shout. That is also an understanding about the world. Okay, that is infer the relevant properties of the world. That is the second component. So every experience it has to infer from every experience. Okay, when this instructor shout or when he does not shout, every time the system has to learn. Then by trying actions and observing the results. For example, braking hard on wet road. Okay, that are experiences. On wet road, how the brake works, and in a dry road, how it works. So that is the third point. That is information about the wave evolves, and the information about the world and its possible actions at every condition. Then when it receives no tip from passengers who have been thoroughly shaken up during the trip. Okay, it can learn a useful component of its overall utility function. Okay, utility function indicating the desirability of the world states. Okay, that means if the journey was not smooth, the passenger will not give tip. So that is the information he has to gather in from these experiences. So it should have the idea about it should learn the utility function. Then the fifth one is action value information indicating the desirability of actions. Okay, all these are qualitative kind of thing in systems. Okay, then action value information indicating the desirability of action. Then the sixth component to be learned is goals that describe classes of states whose achievement maximize the agent's utility. Okay, so we have to maximize the achievement of the goals. Okay, goals achievement. Okay, so it may be accuracy, or it may be the reliability, or it may be the continuity in functioning or something like that. So it depends on the application that we work on. Okay, so that the main the goal, what has to be maximized. Okay, that also should be learned. So these are the six components to be learned. Um, Next, we have the representation of knowledge and representation of the prior knowledge. Okay, we have seen several examples of representation of an agent components. Okay, they talk about their earlier chapters. So the knowledge can be represented using the propositional logic, or using the first order logical sentences. Okay. You can use the propositional logic. That is, you might have heard about the Prolog language that has been used for expert systems. AI and expert systems. So using that means the knowledge is represented as a set of rules. Okay, so we can use the predicate logic or propositional logic to represent those rules. Okay, so knowledge basically stored in the form of some rules. Okay. Then another thing is Bayesian networks have been used to store the information or to store the knowledge, okay, for the inferential component of the decision theoretic agent and so on. So different methods are available to store the information. So we can use the mathematical representations, the proposition logic and predicate logic, to store the rules, to save the rules or to save the information, or we can use the Bayesian networks, and some other methods are also available like decision trees and all. Okay, so in all these we can store the information in form of rules or in some other mathematical forms. So effective learning algorithms have been devised for all these representations. So whatever representation we use to store the knowledge, there are learning algorithms available. Okay, so the inputs that form a factored representation, a vector of attribute values, and output can be either continuous or numerical values. So it's a fact. When we talk about the neural networks, it forms these kind of knowledge representation. It's a factored representation. Input is a vector of attribute values. Input is considered as a vector of attribute values, and output can be a continuous numerical value, or it can be a discrete value. Okay, discrete value, continuous value and discrete value. Suppose your system is trying to identify an image, whether it is a flower or not. Okay, so if you feed an image of a flower, it will give you yes, otherwise it will give you no. So that are discrete outputs. It is either yes or no. That's a discrete thing. There is nothing in between yes or no. Okay, there is no answer in between yes or no. Okay, and continuous means it's a different kind of application. That means your AI system is predicting the temperature. Okay, predicting the temperature for next 3 days. Okay, so the temperature could be it's not a discrete value. It is a continuous value. No, the temperature could be 23.7 or 35.2, like that. Okay, it's a continuous value. So that is the example for continuous and discrete outputs. Okay. Then another thing is the prior knowledge composed of first order logic sentences. So the prior knowledge can be stored in this thing. So they are actually discussing about the chapters, but in chapter 19 they have explained this one. So but we have to understand that the prior knowledge can be represented using first order logic. Okay, and the knowledge or the rules can be represented using the Bayesian network. So different alternatives are there using the predicate or first order logic, and also using Bayesian networks and using decision trees. In different methods we can store the knowledge. Okay. There are two kinds of learning. One is inductive learning, that is from the input-output pairs we can learn. That means, as I said earlier, images of flowers, and the answer is yes. Okay, so the input is the flower, image of flower, and output is yes. So that the input-output pair we can feed and we can train them, and that is inductive learning. Then another kind of learning is analytical or deductive learning. So in that case, what happens is going from a non-general rule, from a general rule to a new rule. we have to derive a new rule that is logically entailed, but is useful because it allows more efficient processing. So from an existing rule we have to derive a new rule, that is analytical or a deductive rule. Okay, this is the first one is we have a set of prior data or prior knowledge. From this prior knowledge we learn. Okay, and in the first thing, in the second one, it is reducing a new rule from an existing rule, or from existing knowledge we deduce something, we deduce a new knowledge. Okay, that is about the and then next thing is the feedback to learn from. Okay, there are actually three types of feedback that determine the three types of learning. Um, so in this feedback system, the three types of feedback, we call them as supervised learning, unsupervised learning, and reinforcement learning. Okay, so how the feedback is given to the system. So based on that, these are the three categories. So in unsupervised learning, the system has to learn from its given data. It has to learn from its given data. There is no labeled data will be given. So in the previous example, I said we feed a image of a flower to the system, and we tell the system that it is flower or not. Okay, so if I feed a flower image of a flower and it says that it is not a flower, I have to correct it. I have to correct the system by saying that no, it is not. It is the image of a flower. Okay, so that is the labeled data. Okay, I label it as flower or not flower. Okay, so from that the system can learn. Okay, that is supervised learning. And in unsupervised learning there is no such labeling. We will give a set of data to the system, and it has to identify, or it has to group um, these data. So one example of unsupervised learning is clustering. That means suppose we feed the system with a set of images. So it has to images like images of flowers, images of human being, images of some fruits. Okay, so it from by learning the similarity of these images, it has to group all the images of flowers. Okay, all the images of flowers into one cluster or one group, all the images of fruits into another cluster, into another group, and all the images of human being to a third group. Okay, so we are not actually telling, or we are not actually labeling the images like it is flower or it is human being or it is fruit. We are not labeling like that, but still by understanding, by studying the understanding the similarity of the images, it has to group into different categories. Okay, that is an example of clustering. Clustering is an unsupervised learning method. Okay, so without labeled data, without any knowledge about the images or about the input, it has to learn itself. Okay, that is unsupervised learning. Then second one, uh, okay, the first one is actually supervised learning. We give them a labeled data, and using that labeled data we train them, and after training, if we give an unlabeled data, it can identify. That is a supervised learning. Then the third category is reinforcement learning. It's a series of reinforcement. That means when it do right thing, we have to give them a reward. Okay, we have to give a reward to the system, and if it is if it is giving a wrong answer, we have to punish it. Okay, so that is the reinforcement we do. So from this, it has to understand that okay, it was when it get rewards, it understand that okay, it was good, it was the right thing. and when it gets punishment, it understand that okay, it was the wrong thing that it do. It should not repeat it in the later stage. Okay, so these three are the learning methods, main learning methods. Main categories are these three: supervised, unsupervised, and reinforcement learning. So these are actually the feedback system, how we give the feedback to the system in order to learn. Okay, so these are the three methods, and there are many algorithms coming under all these three categories. Okay, semi-supervised, supervised, unsupervised, and reinforcement learning. And there is another term called semi-supervised learning. That means we have some labeled data and some unlabeled data. Okay, so from this the system has to identify. So it's a mixture of supervised and unsupervised learning method. Okay, so these are the mainly there are three feedback systems: supervised, unsupervised, and reinforcement learning.